Bismillahirrahmanirrahim. Exercise 3.3, question number 13. Integral ax divided by square root of a square minus x4 into dx. The previous knowledge which we need here is integral of dx divided by a square minus x square inside the square root is equal to sine inverse x by a plus c. This integral, we must know this result and we are going to use this result in this given integral. Okay, let's start the work. I have named the given integral as I, and I'm just going to adjust it a little bit. I'm going to write it like this. I'm bringing this a outside and I'm writing it like this: x dx divided by a square minus x4. Here it is. Okay, now let's take some substitution here. I'm taking x square is equal to y. As a result, what will happen? X4 will become y square. And I take differential on both sides. Differential of x square equals to differential of y. Differential of x square means derivative of x square into dx equals to dy. Now you can see we have x dx here. So we remove this 2 and we get x dx is equal to dy by 2. Now we are ready for our substitution. So we get to our integral I, which is, let's adjust this implies symbol. This is a better shape for, let's go for it. Integral, let's go for our integral. It implies that our integral I becomes, a is outside. In place of x dx, I'm going to put dy by 2. Dy by 2, and what happens here? Square root of divided by square root of a square minus y square. A square as it is, and in place of x4 I put y square. Now I bring this by 2 outside, so it becomes a by 2, and integral becomes dy divided by a square minus y square. If you don't like to write this as dy by 2, you may also write it like this: a here and 1 by square root of a square minus y square into dy by 2. It's your choice. If you want to write it like this, you can write it like this. If you want to write it like this, it's your choice. No difference in the two cases. Okay. And now we perform the integration a by 2 as it is. And this integral, you can use this result, and this integral becomes sine inverse y by a plus a constant of integration. And now put the value of y. What was the value of y? It was x square. So I get a by 2 sine inverse x square by a plus a constant of integration, and our integral is complete.